Welcome. So we are now in the Data and Statistics unit, which is the final unit for 6th grade here. I created these two guides to help you with the different types of graphs you'll see, such as like dot plots, histograms, and you'll learn about mode, and range, and median. So I do suggest looking through this. Mean is the average of something. You find that by adding that all together and dividing it by the number of something that you have. So let's say I have 10 students in the class. They all got 10 different scores. I add up all their scores and then divide by 10. That finds you the average. Mode is the most common occurrence. Like if, say, 5 out of 10 students got 85 for their score, that would be the mode. And range would be the difference between the maximum and minimum value, of course. The median is the middle value, but you must put it in order from least to greatest. So you also see statistical questions in this unit, which is if something can be answered. So it says here that a question is a statistical question if it can be answered with data that varies. The answer is a percent, range, or an average. So you cannot ask someone, hey, did you get up this morning early? Because that's a yes or no question, right? There's no data that will vary. So, what did Tom eat for lunch? How many brothers does Martha have? These are non-statistical data questions. Statistical data questions would be, what do 7th graders prefer to eat for lunch? It's a little more specific. What time do the students in this class get up this morning? It's more specific, right? And these are the different types of distributions: normal, right skewed, left skewed. Notice that right skewed is not to the right, it's to the left. I know it's backwards, but that's how it should be. Right skewed is to the left here. It goes, I guess, biggest from left to right, and then small from left to right is left skewed. Uniform distribution, normal distribution, symmetric distribution. You can see it's symmetrical in the middle, and non-symmetric because it's not symmetrical in the middle. These are dot plots. You'll see some of these in this unit, and this is just, once again, going over mean, mode, and things like of that sort. So let's practice some questions together. Okay, so how many more festivals had 18 to 23 countries represented? Wait, how many more festivals had 18 to 23 countries represented? So you can see here, these are the number of countries and these are the number of festivals. This here is 18 to 23. And you can see here it stops at 4. So there have been 4 festivals. How many more festivals had 18 to 23 countries represented than 0 to 5 countries? And this is 1, right? So this is at 4, and 0 to 5 here is at 1. So you can see there were 3 more festivals. And that's how you would read the histogram. Is this a statistical question? How many acorns do squirrels typically eat in a day? So remember, we can go back to our statistical questions here. So you're asking for a number, right? How many squirrels, how much do they eat typically in a day? It's pretty much, yeah, it's very specific. In a day, squirrels, acorns, and it's statistical questions, it says, are answered by collecting data with variability, meaning the data varies. It could be 3, it could be 5 acorns, 100. The following data represents the number of trick-or-treaters James had each year. Using this data complete the frequency table. Okay, so let's see. Are there 52 for any of the years? No. Is there 53? Yes, for one of the years. Is there 54? Yes, for 2 of the years. You see it repeated there twice. 55, one of the years, and 56, 2 of the years. So you see here 2, 4, 5, 6. 1, 2, 3, 4, 5, 6. So making sure I got all of them. And that's how you fill that frequency table out. Dot plots are easy to create. You put the dots on top, right? 3 occurs once. Oops. 4 occurs once. 5 occurs twice. And 6 occurs twice. And that's how you create a dot plot. Very simple. This looks kind of too zoomed in. The following data points represent, okay, so they want you to create a histogram. So from 0 to 100, there is 1, 2. So you want to go to 2, right? Pull your bar up to 2. From 100 to 200, there are none. And from 200 to 300, there are 1, 2, 3, 4, 5, 6. And so that would be our histogram. Very simple. Beginning of this unit, very simple. Which of the following is a typical number of cavities one patient had? So you can see number of cavities for one patient. So this is 63 patients in the past month. They want you to find a typical number, so like the average. So you can see that there's so many of them. I guess we can count them. That probably would be easier, but it looks like on most of them we're in the 0 to 3 range over here, right? Definitely not 15, definitely not 7 cavities, and definitely not 5, which the following is a typical number of cavities one patient had. So 2, you can see here, 2 and 5 are pretty much the same, but most of the patients had between 0 to 3 cavities, right? So kind of in the middle of there. 2 would be the better option. So this is when you're going to start seeing mean and mode and things of that sort. Laura is a wildlife researcher. They were analyzing the mean and median lengths of 7 fish from their team. Fish their team observed. The fish had different lengths. Laura found out that they were misreading the longest length. It was actually 83 and not 33. How will this length affect the mean and median? So if I had, for example, 15 plus 33, and I divided that by 2, what would that get me? So let's see. 15 plus 33 would be 48. Divide that by 2. The average would be 24. And the mean would be somewhere in between there, right? So then if I had 15 and 88, and I added that together, and I divided it by 2, I would get 51.5. So you can see that the mean increases. So the mean will definitely increase. The median would, we don't have all the data of the 7 fish, but the median is definitely going to be higher as well, since the number is higher. Wait, hold on, let's look at this. So the mean will increase, but the median will stay the same. Let's see, we don't actually have the data, so it's kind of hard to say. Let's see how they figured out the median. So there are 7 fish. When the lengths are in order from least to greatest, the median is the 4th length. The fish that was 88 centimeters long was the longest both before and after their length was corrected. So their 7th. Oh, did they say the 7th fish? So I guess only one of the fish had the longest length. And so like that's what changed. And so the median stayed the same because it's the middle number. So that's why. That's the reasoning for that. And that makes sense. They should have been more specific in their problem, but it's okay. Find the mean of the data. Okay, so 2 ones is for every little thing you see. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21, 22, 24, 26. So there are 26 wands. We need to divide by the number of people. There are 4. So if we did 26 divided by 4, the average wand would be 6.5. It would be the middle. Or did they not? Or they might have divided by the number of each one you see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's see how they did this one. 28 divided by 4. Oh, they did not tell me to round. Okay, so they're not being very specific in their questions. We did that. We added all of them together, and we divided by the number of people, but I guess we should have rounded it to the nearest whole number. They should have said that. Find the median and the number of children. Okay, so you want to put this in order from least to greatest. So there were 3 members who had 1 children, 2 members who had 2, 1 who had 3, and 1 who had 5. So maybe I should do this. 1 children, 2 children, 3 children, and 5. So the median would be the middle. So we meet right in the middle here, right? There's 3 on each side. So the median number of children would be 2. Make sure you put it in order from least to greatest. The following data points represent the number of chicken nuggets on each family member's plate. If the mean of the data is 3, find the missing number. So we just need to add all of this together, right? 1 plus 3 plus 0 plus 6, which is 10. So 10 plus what divided by 2 is going to get you 3. And that's what you're going to find. So this is pretty much, a 2-step equation. I can multiply, I can do it in my head. Or I can multiply both sides by 2. And then subtract 10. Or let's see, I'm trying to think of the easiest way to do this for a 6th grader. Let's plug in numbers. If I plugged in 1 here, I would get 11. 11 divided by 2 is not 3. If I plugged in a 2, 12 divided by 2 is not 3. I need a greater value. I need to get to 30. No, not 30. What divided by 2 will get me 3? 6. Okay, so if I plugged in, actually, let's take a step back. 10 added together plus what divided by the number that there are. That's why 1, 2, 3, 4, 5. How many are there? 1, 2, 3, 4, 5. There are 5. So let me actually rewrite this. 10 plus what divided by 5 equals 3. Okay, so now it will work. If I multiplied each side by 5, I would get 15. And then I can minus 10. And I will get 5. So 15 divided by 5 is 3. So the other value would be 5. You can set up an equation, or you can pretty much do it in your head, right? You want to get to 15, because 15 divided by 5 is 3. Sorry about that. Having a little bit of trouble with the second quiz here for whatever reason. Sanjay tried to find the median from the following dot plot, which shows how far he went on his recent walks. However, he made a mistake. What mistake did he make? So the number values are 5. There's 2 6s, 1 7, 2 8s, and 2 9s. There are 8 values, 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's right. And he said, so the middle value is the 4th value, which is not true. So he found the median wrong. He ordered them from least to greatest. He should have averaged the 2 middle values instead of just 1. So when you're doing median, and this is very important, if you do not have an exact middle number, then you average the 2 middle, right? You add them together and divide by 2. And that's where Sanjay was wrong. So good luck with part 1 of this unit. Let me know if you have any questions. Good luck.